So I don't think, I think that the statement of this week's lab gives you a lot of guidance already, so I don't need to go into too much detail, but I wanted to talk about two different topics. The first being compile time integral constants. So often we want to define a symbol that has a single integral value, which you see this term pop up, and it means it's just an integer value. I know. It's really a tricky word there. I don't know why they don't just say integer value, but I try to use the lingo throughout, integral value throughout our program. So it's actually the adjectival form of integer is integral, but it's almost never used. So, fortunately, C lets us do that many ways. Unfortunately, it can be hard to choose among them. So this is like one of the problems of the curse of options. So the primary ways of defines or macros, so the primary ways are defines, which are called macros, enums, which are called enumerations, and constant ints. So we talked a little bit about macros, defines, and constant ints before, but just in passing. So I wanted to revisit them in a little bit more detail. When choosing among them, our primary concerns are code readability, debuggability, and compile time optimization. The last of these means a compiler or preprocessor before the compiler can replace each instance of the symbol with its constant value, since it never changes. Changes. It never changes. There are subtle differences in how each compiler works, but most of the time, all three of our options yield replaced compile time constants. So they all work to do this compile time optimization. However, defines are the best guarantee because it actually happens before compilation via preprocessing. Enums, a close second. And constant ints, a respectable third. So they all pretty much do the same thing, where it goes through your program before it finishes compiling, at least, so either during compiling or before in the case of the defines. And it replaces all the instances of, say you defined like n. They replace n everywhere in your code with whatever constant integer you want. So like 8. It would just go put 8 everywhere. So instead of having a variable defined and having memory specifically dedicated to a variable, you avoid that. So it's nice to do, but all three of these pretty much get you there. Defines are the most reliable because it happens at the preprocessing level. Each compiler decides how to treat enums and constant ints, but most of them are going to replace them. But enums are the pretty standard. Every compiler replaces enums, and there are some instances in some compilers when constant ints are not replaced, so there is that.
Also, can you like redefine them later on and say?
No. Okay. Well, you can. So
it's like the first.
Before you compile, you can just do it once. So at the top of your file, you can define it, and that's it.
What about like constant ints, where it says like, so n is a constant int and equals 8, and then later on the code I want n to equal 5?
I don't think that you can even do it with a constant int. That might be compiler specific, but I don't think you can. Enums, as we'll see, are going to be like generally kind of like the best, sort of like not too hot, not too cold, kind of in between on each of these, but we'll expand on why that is.
So you mean if we define n equal to 8, you mean in the whole program and subprogram who are in the same file, we have to use n equal to 8 all the time?
Yeah, so then anywhere you see an n in the whole program, it's got to be 8. That's right.
So does that make n global?
Yeah, it's global in that sense. So, and we could say it's a global variable, but it's really not even a variable.
Constant.
There's a constant, and it sort of supersedes everything else because it's done sort of before everything else, at least in the case of defines and enums. The general rule that I follow is I almost never will use a constant int. This is different in C++, but in C, I almost will never use it. Defines and enums is mostly what I stick to. In terms of debuggability, the rankings are probably best reversed. That is, in decreasing debuggability, constant ints are probably the most debuggable, enums are next, and defines are last. Macros, defines, are most difficult because the compiler can't usually give useful error codes related to them, since the compiler typically knows nothing of them due to preprocessing. So if you screw something up with a define, it's hard to catch it. So you got to be a little cautious with that. That is one of the reasons why I prefer to use enums. Enums are a little bit more preferable because enums, the compiler sees them. The compiler is the one that replaces them. So compile errors are easier to understand when you use enums.
But the way they declare this constant is like arbitrary, not really what it is. Something like this. For example, in the day, your example.
Yeah.
You don't get the number.
Right, and we'll talk more about how to do each one, but you're defining, it looks like a variable. It's we call it a symbol. It's a symbol that represents something. And you can write anything in there that you want. You can't use as one of your symbols like int. Like you can't call it like int. Because your program is going to think that you're saying int, the keyword int in C. So yeah, you can't use some things; they're not all allowed, but most things are allowed. Yeah. Okay. Readability is rather subjective, but enums are typically considered strong in this regard, especially with its automatic enumeration of symbols. A way to demonstrate this is to show the same example written these three ways. So I just wrote three different programs that do the same exact thing. Let's define an integral value, used it again, to each day of the week, then write a script that prints a value. So what it does is it's gonna take the difference between the checkout day and today. So 2 different days, and we have an integer assigned to each of these, sequential integer assigned to each day of the week. So you can take the difference, and it should give you a number, an integer that you can print. So enum is pretty straightforward. You can actually declare, this is a type. So you can actually define your own type. So I called it day. You can do anonymous ones where they don't have a type. It's kind of up to you. It's not really, there's not a lot of significance put on the type, but when you declare one later, you have to use the type. So it kind of helps with readability to use a type so that it's explicit in there. Oh, okay. This enum is of type day. So then you define your symbols. So there are 7 symbols for the 7 days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And I could have put them all in one line, or it doesn't really matter, but comma separated symbols. And what enum does is it assigns this one is equal to 0. This one's equal to 1. This one's equal to 2. This one's equal to 3, 4, 5, and 6. So I don't have to do that. It just gives me those integers. So now throughout my code, I can just write Tuesday, Wednesday, whatever, and before while it's being compiled, the compiler will replace every time it says Tuesday with 2, every time it says Wednesday with 3, and so on.
What if I put another enum, like another type? How will it count this sequence?
Yeah, so if you did like enum week, something like that, like
Week 1, week 2,
yeah, so you could do a week type, and then you would open braces and you could call it like week 1, comma week 2, comma yeah, and so these would be 0, 1, etc. It's always going to use 0, 1. You can actually explicitly say, like you could say week 1 equals 7, etc. But if you don't, it's just going to sequentially assign them integer values. And if you give it like, if you say week 1 equals 5, and then you don't write any of the other ones, it'll start at 5 and it'll keep going from there. It's kind of nice.
Can you do something in MATLAB where it's like something in C, like you can do in MATLAB where it's like 1 and then like linspace, how we do linspace, or like the what's that called?
Log space?
No, when you just a colon. Yeah.
Yeah, colon operator to construct arrays.
Yeah.
Yeah. I don't think that these enums have that capability. That's a little more powerful. This is defining a bunch of different symbols. That would be like defining an array with certain values in it. That would be a higher level construction. You could do it in C. You could construct something from this to that in an array in certain increments, but they don't have the nice, C doesn't have that nice, like, from 0 in increments of 0.2 to 5.
Yeah, so
Like,
you'd have to make like your own like for loop or
yeah, I mean, that would be one way to go with it, is just like for each one, then increment it, assign it, increment it, assign it. Yeah, that would be the sort of the C way, that's what MATLAB's doing at some level. I mean, it's got to represent the array somehow, which part of MATLAB is written in C, so could literally be doing it at that. But it is nice. Higher level programming languages let you write this to construct an array. It's pretty sweet, right? I mean, I wouldn't write a lot of scientific computing things in pure C. That's just asking to rewrite a whole lot of things other people have written. So, yeah, it helps when you're doing scientific computing, engineering calculations, using something that allows you to construct an array easily. Just bam. Really nice. Python has similar stuff to that too. So does Ruby. A lot of those high-level languages have stuff like that. C++ does. Okay, so write a main function. Oh, I also defined 2 enum variables, right? So, well, not variables. I defined, yeah, well, I assigned today and checkout to be equal to Monday and Friday. So these have to come from the options. So I couldn't say enum day today equals February. But I could, because that essentially is just saying, oh, this is an enum type, and it's going to be equal to 1. And then in my main, I'm going to print out, just use printf, checkout minus today, and I'm going to say checkout is in that many days. So I run it, checkout is in 4 days. So I defined checkout to be Friday and today to be Monday. So checkout is in 4 days.
Is case sensitive also in the
Yes. Yes. Okay, so I could do the same thing with define, but I have to explicitly say Sunday is 0, Monday is 1, etc. And then I can use the same main function, checkout minus today. So that works too. I would say I kind of like the enum better in terms of like compactness and not having to write everything out explicitly, but not bad. And then the constant ints are similar. You have to explicitly write them out in terms of what their values are, and then do the subtraction, print it out. It also works. So preference among these three options is hotly debated, but it seems enums, so if you look, there are like whole discussions on the internet about this, like which is better, when. It seems enums are the most readable and the just right option in terms of reliable compile time, integral constant replacement, and debuggability. But it's important to remember that defines can be used for much more than integer replacement. Function-like macros, for instance, are very useful. So you can do a macro that looks a little bit like a function. So like Sunday could take an argument or two arguments, and then it would do a replacement. It does a replacement still, pre-processes a replacement, but it actually does it based on a sort of function-like behavior where you could have like of two inputs and then arrange them in accordance to like, so like it could be like define, and you could do like add, for instance, and then it could be like x and y, and then it could be x plus y. So then when you're in your code, you could write, I don't know why you would want to do this, but you could write add of 5 and 7, and then before it gets into the compiler, this macro would replace that with 5 plus 7. So 5 plus 7 would actually be compiled. So you can do that you can do stuff with macros that are obviously much more complex than just assign an integer to it. So if you're just assigning an integer to it, I recommend using enums. But I mean, a define is fine. There's nothing wrong with it. And actually, the source code for this course, a lot of defines are used, which is totally. It's just kind of, some people prefer define. After I read up on it for like an hour, I decided that my slight preference is enums for integer replacement. If it's just an integer, I would say use an enum. But a define works too. Okay, so there's that. Just a little discussion of what those are all about. Now, those all are different than variables, right? Variables are something that has a memory address, doesn't get replaced before the compiler goes through it. After the compiler is done, none of these things exist most of the time afterwards. There's no variable associated with it. Now, constant ints, there are some cases where they do survive as variables, but usually they're replaced. Okay, assigning to a pointee. We already talked about this a little bit. The function fgetskeypad, the source for which is shown in the introduction to this lab, was used in lab exercise 1. Recall that in double in, we supplied as arguments to fgetskeypad a character array and its length. Instead of returning the string, the function wrote to the character array it was supplied. But remember, inside a C function, arguments are assigned automatic variables. How does fgetskeypad assign to the array when it only knows a pointer to its first element? The secret sauce is to assign through a dereferenced pointer. Examine the source for fgetskeypad or consider the following examples. We already pointed it out in fgetskeypad. But in this example, I do a little prototype for function foo. In my main, I define a static integer x equals 0, static integer pointer, which points to x, p, and then I print a before, so I print the value that the pointer points at, which prints to 0, right? Then I call foo, and I hand it the pointer, p. What foo does is it accepts a pointer to an integer, and it assigns the value of the pointer. So the memory location value is now equal to 3 that it points to. So it doesn't have access to the variable x at all. But it still writes to x by this process. So then if we print the dereferenced pointer after foo has run on it, up at the main level, we get 3.
What if you print x?
We should also get 3. So, in fact, do I still have this up?
In this case, we don't
We
write
can.
the return one. Foo is just assigning, not returning.
So foo is not returning anything. I have void there, so it's not returning anything. But it's just assigning this value in memory. At this address in memory, it's assigning 3. So it should be the same address in memory that x is assigned to. But foo doesn't know anything about x. It just knows about the pointer. And the pointer points to that memory address that x happens to be at. And it's saying, oh, okay, well, wherever that pointer is pointing, I want that to be equal to 3. So it can assign to just from the address, yeah. So I get the bounty on this one that we set last time. So note that while this sort of structure is rare among higher level programming languages, it is common in C. For instance, fgets and gets, so file get string and get string, have this same feature. So it's, and I think that if I would venture a guess as to why C has, this is a common thing to do in C, it's because you can't hand, you don't copy full arrays of things and move them around in a C function like you might in another language. You don't say, oh, okay, take this whole array and that's an argument to the function, and then it returns an entire array. Like that isn't something that C does. So when you don't have that, you have to have this ability to deal with arrays and using the pointer directly to let you do that. It is, as I mentioned a couple lectures ago, it is a dangerous thing when you start writing to the value of a pointer because you have a variable that changes value without ever explicitly mentioning the variable in your code. It's really hard to debug something like that. Like you have to know down here that p is a pointer to x and that you handed that pointer to this foo, which has assigned 3 to it. And you never mentioned x again, and yet somehow its value changed. So that is, you have to, I mean, it's powerful, yet it's dangerous. And when you're writing big code and you're trying to debug it, it's really difficult to track down this sort of thing. So I would say use caution. Only use it when you really need to use it, like when you want to write to it at a lower level. But this is more efficient to do it this way, so that's why it's done. You could also use a global variable x. that is just declared in both functions, and you could write to x, which would be easier to debug because you would see, oh, x equals 3 instead of the value that p is pointing to is equal to 3. But, you know, that's why they hire us, to figure out all of these things. They're like, we don't know what's going on in there. We have to have somebody spend hours trying to figure out what this code's doing. So
if we define x is, we define x as constant 3. So when we assign the pointer to number 3, I mean x lost this pointer. It's not the same address anymore.
Yeah, so what we did is we assigned p to the address at which x has its value. So there's some address in memory, blah, 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 and it had 0 initially in it. And then we've got, well, this is like a 2-byte thing. And then in here, so we assigned x to be, so we assigned p to be a pointer to that address. So 0x blah, blah, blah. It points there. Then we handed that to foo, and foo is like, oh, okay, that address in memory, put it a 3. Put a 3 in there. And then now x is still this address in memory. So now x is equal to 3, but we never said anything about x down here.
What I ask is that if we take x to the above one, we define it as constant 3. Can we assign this constant to a pointer?
So if we said x is equal to 3.
And define x equal to 3. No, not in the same line, but above the main. I mean.
Oh, up here.
Yeah.
So if you define up here, I believe the global, it's defined as global.
Yeah.
However, globals are not available to a function unless you declare it in the function. So if you said, what you would do, it's best to just write, so if you're going to write this, you should write extern x equals 3. And then, well, you should do int. Int x equals 3. Then in here, you would write, instead of that, you would write, say, static
Int x.
int. I don't know if you can say static. I think you just have to say extern. Extern int x. And that would make x out here and x in here the same. You would bring the global into your main function by declaring it. So then you would have access to x, the global variable.
Always 3. Even though
Always 3.
we appoint
And
pointer to 4, it will be x. When we use x again, it will be 3.
so if we point to it and then we overwrite where that pointer is pointing, then it would change. Then it would change.
It was a constant character, or?
But this is this we didn't do const. I think that your compiler would throw an error if you wrote const and then you tried to overwrite it. It may or may not throw an error. You shouldn't want to overwrite a const, and if you do, I think it should be an error.
Okay.
I know it would throw an error if you explicitly tried to reassign it. I don't know if you can sneak in the back door and reassign it using a pointer.
Yeah.
Should try not to sneak in the back. This is the same thing. Don't be malicious to your own software. Okay.
Because it's just wonder if.
We can play though. Let's play.
Yeah.